Welcome, Achievers. This is Chapter 13, Section 1, Volcanoes and Plate Tectonics. Volcanic eruptions can cause some of the most dramatic changes to Earth's surface. Some eruptions can be more powerful than the explosion of an atomic bomb. The cause of many of these eruptions is the movement of tectonic plates. The movement of tectonic plates is driven by Earth's internal heat. By studying temperatures within Earth, scientists can learn more about volcanic eruptions. Figure 1 shows estimates of Earth's inner temperatures and pressures. As the graph shows, the combined temperature and pressure in the lower part of the mantle keeps the rocks from below their melting point. Formation of magma. Despite the high temperature in the mantle, most of this zone remains solid because of the large amount of pressure from the surrounding rock. Sometimes, however, solid mantle and crust melt to form magma, or liquid rock that forms under Earth's surface. Magma can form under three conditions. First, if the temperature of rock rises above the melting point of the minerals that rock is composed of, the rock will melt. Second, if enough pressure is removed from the rock, the melting point will decrease and the rock will melt. Third, the addition of fluids such as water may decrease the melting point of some minerals in the rock and cause the rock to melt. Figure 1. Temperature and pressure increase as depth beneath Earth's surface increases, so rock in the lower mantle stays below its melting point. Volcanism. Any activity that includes the movement of magma onto Earth's surface is called volcanism. Magma rises upward through the crust because the magma is less dense than the surrounding rock. As bodies of magma rise toward the surface, they can become larger in two ways. First, because they are so hot, they melt some of the surrounding rock. Second, as the magma rises, it is forced into cracks in the surrounding rock. This process causes large blocks of overlying rock to break off and melt. Both of these processes add material to the magma body. When magma erupts onto Earth's surface, the magma is called lava. As lava flows from an opening or vent, the material may build up as a cone of material that may eventually form a mountain. The vent in Earth's surface through which magma and gases are expelled is called a volcano. Major volcanic zones. If you were to plot the location of the volcanoes that have erupted in the past 50 years, you will see that the location form a pattern across Earth's surface. Like earthquakes, most active volcanoes occur in zones near both convergent and divergent boundaries of tectonic plates, as shown in Figure 2. A major zone of active volcanoes encircles the Pacific Ocean. This zone, called the Pacific Ring of Fire, is formed by the subduction of plates along the Pacific coast of North America, South America, Asia, and the islands of the western Pacific Ocean. The Pacific Ring of Fire is also one of Earth's major earthquake zones. Figure 2. This map shows the location of major tectonic plate boundaries and active volcanoes. What is the relationship between the volcanoes and tectonic plate boundaries? Subduction zone. Many volcanoes are located along subduction zones where one tectonic plate moves under another. When a plate that consists of oceanic lithosphere meets another that consists of continental lithosphere, the denser oceanic lithosphere moves beneath the continental lithosphere. A deep trench forms on the ocean floor along the edge of the continent where the plate is subducted. The plate that consists of continental lithosphere buckles and folds to form a line of mountains along the edge of the continent. As the oceanic plate sinks into the asthenosphere, fluids such as water from the subducting plate combine with crust and mantle material. These fluids decrease the melting point of the rock and cause the rock to melt and form magma. When the magma rises through the lithosphere and erupts on Earth's surface, lines of volcanic mountains form along the edge of the tectonic plate. If two plates were to have oceanic lithosphere at their boundaries collide, one plate subducts and a deep trench forms. As in the case of continental lithosphere colliding with oceanic lithosphere, magma also forms as fluids are introduced into the mantle during oceanic plate collision. Some of the magma breaks through the overriding plate to Earth's surface. Over time, a string of volcanic islands called an island arc forms on the overriding plate, as shown in Figure 3. The early stages of this type of subduction produce an arc of small volcanic islands, such as the Aleutian Islands, which are in the North Pacific Ocean between Alaska and Siberia. As more magma reaches the surface, the island becomes larger and joined to form one landmass, such as the volcanic islands that joined to form the present-day Japan. Reading check. When a plate that consists of oceanic crust and one that consists of continental crust meet, which plate subducts beneath the other plate? Mid-ocean ridges. The largest amount of magma comes to the surface where plates are moving apart at mid-ocean ridges. Thus, the interconnected mid-ocean ridges that circle Earth form a major zone of volcanic activity. As plates pull apart, magma flows upward along the rift zone. The upwelling magma adds material to the mid-ocean ridge and creates new lithosphere along the rift. This magma erupts to form underwater volcanoes. Figure 4 shows pillow lava, an example of volcanic rock that forms underwater at mid-ocean ridges. Pillow lava is named for its pillow shape, which is caused by the water that rapidly cools the outer surface of the lava. Most volcanic eruptions that happen along mid-ocean ridges are unnoticed by humans because the eruption that takes place deep in the ocean. An exception is found on Iceland. Iceland is one part of the mid-Atlantic ridge that is above sea level. One half of Iceland is on the North American plate and is moving westward. The other half is on the Eurasian plate and is moving eastward. The middle of Iceland is cut by large fissures, which are cracks through which lava flows to Earth's surface. Figure 5. As tectonic plate moves over a stationary mantle plume, volcanic mountains form. Above, the Hawaiian Islands to the left formed in this way. Hotspots. Not all volcanoes develop along the plate boundary. Area of volcanism within the interior of the lithosphere plates are called hotspots. Most hotspots form where columns of solid hot material from the deep mantle called mantle plumes rise and reach the lithosphere. When the mantle plume reaches the lithosphere, the plumes spread out. As magma rises to the surface, it breaks through the overlying crust. Volcanoes can then form in the interior of a tectonic plate, as shown in Figure 5. Mantle plumes appear to remain nearly stationary. However, the lithosphere plate above a mantle plume continues to drift slowly. So the volcano on the surface is eventually carried away from the mantle plume. The activity of the volcano stops because a hotspot that contains magma no longer feeds the volcano. However, a new volcano forms when the lithosphere has moved over the mantle plume. Other scientists think that hotspots are the result of cracks in Earth's crust. The theory argues that hotspot volcanoes occur in long chains because they form along cracks in Earth's crust. Both theories may be correct. Reading check. Explain how one mantle plume can form several volcanic islands. Figure 6, Devil's Tower. In Wyoming is an example of a pluton called volcanic neck, a formation caused by cooling of magma within the vent of a volcano. The outer part of the volcano eroded, only the volcanic neck remains. Intrusive activity. Because magma is less dense than solid rock, magma rises through the crust toward the surface. As the magma moves upward, it comes into contact with or intrudes by overlying rock. Because of magma's high temperature, magma affects surrounding rock in a variety of ways. Magma may melt surrounding rocks or may change the rock. Magma may also fracture surrounding rock and cause fissures to form or cause the surrounding rock to break apart and fall into the magma. Rocks that fall into the magma may eventually melt, or the rock may combine with a new igneous rock, which is rock that forms when the magma cools. When magma does not reach Earth's surface, the magma may cool and solidify inside the crust. This process results in large formations of igneous rock called plutons, as shown in Figure 6. Plutons may vary greatly in size and shape. Small plutons called dikes are tabular in shape and may be only a few centimeters wide. Batholiths are larger plutons that cover an area of at least 100 square kilometers when they are exposed on Earth's surface.